Alright, so if you've already watched it, I just finished my last update out here in the loft. I actually haven't moved. But now I'm going to do my video on sex-linked breeding. So if y'all saw it, I did a video on pigeon genetics just a couple of days ago. I've had it loaded for a few days on YouTube. And but I never really talked about how important different genes can be, or how to get certain things from others. So all I did was talk about just the genetics behind the bird's colors, patterns, modifiers like these grizzles or these bald-headed rollers, which have a piebald gene in there. Piebald might not be considered a modifier, but grizzle certainly is. Grizzle certainly is affected by the pattern. Piebald isn't so much. So piebald's pretty easy. But first I'll explain to you a little bit about how some of these genes are passed on. If you know anything about genetics at all, I mean, if you've made it through high school, you shouldn't, and I've not even made it completely through high school yet, but if you've even gotten past, you know, the 10th or 11th grade, you probably should know that people, and I believe all mammals have X and Y chromosomes. Guys have XX, females have an X and a Y, and when animals breed, or people, you know, and make babies, we donate one of the two chromosomes that have, you know, basically half our copy of genes. It's not so much that, you know, that chromosome only has the genetic code for my head to my belly button, or from my belt down. It's that every thing that makes me me has two genes for it. It may be two dominant ones, two recessive ones, or a dominant and a recessive. Y'all probably know enough about genetics to know what I'm talking about. And only one of those versions gets passed on. So it's not that all the genetics isn't there. All the right kinds of genes are there. You just takes two of them. So pigeons are the same way, except they don't have X and Y. They have... Now that I want to tell you, we're having we like to call this a brain fart. You immediately forget the one important piece of information you were about to tell someone. Oh, what chromosomes do they have? Because they don't have X and Y. It's called something else. But it doesn't matter an awful lot. It just makes it easier to tell you. I'll remember as soon as I turn off the camera. But for the same way that a guy has two X chromosomes and a girl has an X and Y chromosome, pigeons work the same way. It's just not called X and Y. I don't remember what it's called now. But we'll just call them boy chromosomes and girl chromosomes, because if a pigeon has one of the girl chromosomes, it makes it a girl. And if it doesn't have a girl chromosome, and it has two boy chromosomes, it's a boy. So it's not necessarily that the two, we're going to call them boy chromosomes till I remember what they're called, are, it's not so much that they make the pigeon a male. Just think of it more as the girl chromosome makes it a female. And if it doesn't have one, then it's a guy. But most of the things, like color, are carried on. They're like color. I don't remember specifically about pattern, but things like color or dilute is, I know, are carried on the. We'll call them the boy chromosomes because I can't remember what they're called. Again, I'll remember as soon as I turn this off. And I don't think spread is. But basically, that means that the cocks, like take Coco over here, for example, have two color genes. And he's busy building a nest, so you can see he's carrying his pine needles over and they're making a nest. But he has two color genes in him. One obviously being ash red, the dominant one, which is showing through. But I believe he also has blue in him, I think. I don't know that for sure, but I'm pretty sure it's most likely that he does. Whereas Swift over there, the hen sitting on the nest, she only has one color chromosome, obviously being blue, because she's a blue pigeon, probably a blue bar. She could be a blue check, it's hard to tell with the grizzle. But, and it would work the same way. That right there is a blue check hen. She only has one gene, the blue. As far as I know, he has two color genes. At least one obviously being blue. The second one is probably also blue. It's possible that it could be brown, but you almost never see brown pigeons, so it's probably blue. But what that means, it doesn't sound like it means an awful lot at the moment, but it means that the male, he's always going to pass on one of his color genes, whereas the hen could pass on a color gene, but because she only has one, if she passes on, we'll call it the girl chromosome, to her offspring, which would make it a hen, she won't do so without passing on the color, because color is not carried on the girl chromosome. It is really, really bothering me that I cannot remember what they're called. So she has to make a choice. I mean, she doesn't actually make a conscious choice. It's a 50-50 chance. But one or the other is going to happen. She either passes on color, and her offspring is a male, or she passes on what we're calling the girl chromosome, and the offspring is a girl, and her color is decided solely by the father. And again, that's interesting. You know, you might say, well, that's interesting, Dustin, but that doesn't really affect me. All I'm trying to do is breed out racing homers that race quickly. Or maybe you raise rollers. All I want is rollers that roll really well. Or maybe you do breed for color and you say, well, you know, that's interesting. But I don't see where that helps me too much. But something that we can do with that knowledge is perform a sex-linked breeding. What that is basically, we all know that pigeons cannot be, their genders cannot be identified just by looking at them. You know, it's not like, we have cardinals where I live. It's not like with cardinals where the red ones are males and the brown ones are females. And it kind of works that way with most songbirds. The drab-colored ones are girls, the bright-colored ones are males. That's not really how it works in pigeons. That right there is a hen, and that one right there is a cock. And they look almost exactly the same. And the little bit of difference there is not because they're genders. But with that sex-link, those sex-linked genes in mind, we actually can. So I'm actually performing one, probably two sex-linked breedings. I didn't do them intentionally, but I am doing them, so I'll use them as examples. In here, if y'all been keeping up with my updates, you know I've got this indigo spread cock roller cock being bred to this ash red satinette hen. Now, because he's got indigo, well, because he's got spread, the color is all over his body, and because he's got indigo, it makes it lighter than a black color. And those genes are something completely different, so don't even worry about that, and don't worry about the piebald white on his head, or his piebald on his wings, or there's little on his tail. All you need to worry about is the fact that he is blue base. That is, his base color is blue. And this satinette in here, which looks mostly white, but you can't see her very well at the moment, but she's ash red. You can see the kind of redness to the side of her. Okay, you can't see it very well, I'll admit. It's not a real great example for looking at, but it's an ash red hen. So all we need to worry about is that the girl, she has one girl gene. Can't remember what it's called, what the chromosome's called. Alright guys, I'm back. I just had to restart the camera or it'll cut off. It does that after 10 minutes. So back to what I was saying. Let's pretend that when those eggs hatch, we get one boy and one girl. The girl is going to have the girl chromosome donated by the mother, and the boy chromosome, which doesn't really make him a boy necessarily, donated by the father. And the boy chromosome is going to carry color. Now, she's only going to have one gene for color, since the girl chromosome doesn't have color on it, since her father is blue, and I think he just carries blue. He's blue as far as I know. Then she will be blue, because she doesn't have any other colors to work with. It's just the blue donated by her father. Now, if the hen that we're looking at right now, the mom donates her boy gene, it's what we're calling it for now, because I can't remember what it's called, that has color on it, and it has only the color ash red. That's the only color she can be. That's the color we see. It's the only one she carries. She donates the ash red, and because the cock, assuming he's blue, I believe he is, he'll donate a blue. Now, we know an ash red and blue gene on a bird is going to make it ash red, because the ash red is dominant and will show through. They will carry blue, but they will look ash red. So there's no other way it can happen. So all of the males that they ever breed out, this pair, are going to be ash red and carry blue. And all the hens are going to just be blue. And carry the girl gene, obviously, which makes them girl. Again, I wish I could remember what that's called. But that's how sex-linked breeding works. Is the hen, you take a dominant gene, which can only be found on the male chromosome. I can't remember what it's called. I want to say the male chromosome is the Z one, the Z chromosome. And you pair it to a cock that has 2 of the recessive of that kind of gene, and all of your cocks will be the dominant gene, and all your hens will be the recessive gene. Same thing works with dilute. If he was dilute, and she didn't have any, which we know she doesn't, let's just pretend instead of being indigo that he was dilute, then all the babies they bred out that were dilute would be hens, because they would have gotten the girl gene from her and the male gene from him, which carries dilute. And the girl gene can't carry dilute or non-dilute. I guess there's a non-dilute gene, I don't know. But all the girls would be dilute. And all the cocks would get, you know, her male gene without, which does not have dilute on it. And so none of them would look dilute. They would all just be, you know, pretend she was also blue, and then they would all be blue, but they would carry the dilute gene, but you wouldn't see it. So that's basically how sex-linked breeding works, and you can do that with any genes that are carried only on the male chromosome. Again, really wish I could remember what it's called. I'll include the names of those 2 chromosomes and which one they are in the end of my video. I'm telling you, this is what we call a brain fart. But I will do that, and I'll include some links to some helpful websites on pigeon genetics in the end of my video, and I hope that was helpful. I did want to talk about a little more than just sex-linked breeding, so I will say piebald. I told y'all that it was easy in my last video. I told y'all it was easy to set. What that kind of means is if you excuse me, I burped. If you have 2 pigeons with this piebald gene that causes them to be white in the same area and breed them together, you'll get white in the same area again most of the time. That pigeon right there, they're a pair. They both have white on the ends of their wings, and they both have white heads. When bred together, they've already had 2 babies, which I don't have on hand to show you right at the moment. But both their babies have white heads and have white wings, just like both their parents. However, he has a white tail and she has a solid colored tail. And the white on his tail being caused by piebald. When bred together, the babies this time have had mostly dark tails with, or sorry, not mostly dark, mostly piebald tails. They've been mostly white with a few dark feathers. I know the older of their babies has just one dark feather on its tail, and I'm just talking about the big feathers. I'm not talking about the little ones near the base. And the younger of their babies, I want to say it has 2 or 3 dark feathers, but it's mostly white. And again, next time they could be mostly dark tails with a few white feathers, but they're almost certainly going to have completely white heads and white on the, they're about half their wings are white, and that should be duplicated again, their babies, and that should happen pretty much every time. Occasionally you'll get some oddballs that aren't quite right, and a lot of times piebald, in my experience, seems to spread a little bit. It really seems helpful every now and then to take a bird which doesn't have enough white on its wings and breed it to a bird that has too much, and their babies are kind of evened out. And as most people that breed any kind of animal know, if you want a bird to look a certain way or an animal to look a certain way, you need to take one that has more of whatever you want and breed the one that has less of whatever you want to get them to meet halfway in the middle and get it to you just right. If you take 2 perfect looking animals and breed them together, they usually will not give you perfect looking offspring. Again, just another tip there, which doesn't matter too much in racing homers and rollers, but if you're breeding something that you want to look at, you want some, you're worried about what they look like, then that'll hopefully be helpful to you. But I think I'm probably going to leave it there. I already explained in my last video about things like grizzle that show up when there's only one gene, but are even more evident, look different when there's two of those genes in them. Same thing goes for indigo. I explained that in my last video, so I think I'm gonna cut it off here. If y'all have any questions, feel free to leave them in the comments. I'll do my best to answer them. Whether I know the answer or not, I probably know someone that does. And if your question's about satinets and the way they look, I'm afraid I'm not going to be much of a help to you. I'm still trying to figure that out myself. So if you know a bit about breeding satinets and how to get these colors and stuff into, like I said, I'm crossing them with rollers right now. I want to make frill stencil rollers. I was told that there's actually 4 genes that control that pattern on their wings. You know, if you want to share some of your knowledge about that, I'd be happy to see it. And I love that y'all are commenting on all my videos. Lots of great input. I've had people tell me things I didn't know. Like I used to think these were ash red spreads when they're in fact not. An ash red spread would be light gray. I had no idea. So, you know, I really love the feedback. Make sure to keep commenting. Again, if y'all are leaving questions for me particularly about myself, here in the next few days I'm going to do a video and answer some of those questions. I actually haven't gotten a lot yet, so I'm just kind of holding off a little bit until I get some more questions to answer. And again, that being in honor of my reaching 100 subscribers. Now I think I'm like up to 112 or something, so I really appreciate it, guys. Keep on liking the videos, keep on subscribing. But keep watching. Thanks for watching, and take care.